The construction industry is one of the most hazardous in America, and the potential for fatal accidents exists at every work site. The number one killer of construction workers? Falls.
Each year, a few more than 6,000 people die in work-related falls in America. It is alarming to learn that by the end of the 1990s, construction workers with only 4% of the workforce were suffering over 50% of the fatalities. And the price of falls reaches beyond the pain and suffering of the victims and right into your pocket.
It has to be understood that there are 6 fatalities in the construction industry every day, and of those 6, 2 are from falls from elevations. So we have to manage this problem.
The rule requires you to provide fall protection and training for any worker who's exposed to a fall of 6 feet or more. Subpart M applies to all construction sites and activities except where more specific standards like scaffolds, ladders, and steel erection apply.
The contractors have to recognize that we have exposures to falls from elevations all over our job sites.
Our goal is to identify all fall hazards and then eliminate them before the work begins by pre-planning. For example, you can order permanent stairs with guardrails already attached. So, if you can't engineer the hazards out or eliminate them, you'll have to guard against them. Your first set of options includes hole covers and 3 conventional fall protection systems. These systems are guardrails, safety nets, and personal fall arrest systems. OSHA considers any holes 2 inches or more in diameter at 6 feet or more above a lower level to be a fall hazard. And covers are one way to eliminate this hazard. But remember, workers can still be injured even if the hole is less than 6 feet above the lower level. So to eliminate the possibility of these injuries, cover all holes on the job. The covers have to support at least twice the weight of any employee who may be on the cover. This includes equipment or material the worker might be carrying. Covers in areas where scissor lifts or other construction vehicles are being operated are required to support at least twice the maximum axle load of the heaviest vehicle expected to cross over the cover. The covers have to be secured so they can't be easily removed by workers or displaced by wind or equipment. And finally, they must be color-coded or have the word hole or cover written on them. The first of the conventional systems, guardrails, are commonly used on open-sided floors, around floor and roof openings like skylights, on stairs, and on ramps or walkways. Whether made of wood, rope, or steel, all guardrails must meet specific design and structural requirements. Avoid using manila, plastic, or synthetic rope for railings because these materials are easily damaged and must be inspected far more often than wood, pipe, or steel. Under no circumstances can you use steel or plastic banding for railings. All railing systems must be smooth-surfaced to prevent injury. Top rails must withstand a force of at least 200 pounds applied in a down and outward direction. They are required to be between 39 and 45 inches above the working surface. But remember, when you apply the 200-pound downward force, the top rails must never sag below 39 inches. Make sure mid-rails are installed halfway between the top rails and the working surface. If screens or mechs are used in place of the mid-rails, they must extend from the top rail to the working surface and along the entire rail system. And the mid-rails, or any screening material used, has to support a force of at least 150 pounds. All railing systems must have toe boards that are at least 3.5 inches high. The posts, wood, pipe, or angle iron, must be spaced no more than 8 feet on center, and the ends of all top and mid rails should not extend beyond the corner or end posts.
For wood guardrails, construction-grade lumber should be used. At a minimum, 2x4s for the posts and top rails and 1x6s for the mid-rails. Pipe railing systems are required to be at least 1.5-inch outside diameter Schedule 40 pipe. If you use angle iron, it must be at least 2x2 by 3/8 inch stock. Another option is the wire rope guardrail system. The top and mid rails can't be any smaller than 1/4-inch cable and need to be flagged at least every 6 feet with a highly visible material, like caution or surveyor's tape. The wire rope must also be properly tightened so that when the 200-pound force is applied, it doesn't sag below 39 inches. A second conventional fall protection system is the safety net. Safety nets are most commonly used for steel erection, bridge construction, and large commercial projects. It's important to remember that you can't use just any net, because the safety nets are specifically designed for fall protection. The mesh crossings must be secure, the net openings no more than 6 inches by 6 inches, and the border ropes or cables capable of supporting 5,000 pounds. When installed, the nets have to be placed as close as possible, but no more than 30 feet below the highest working surface. All safety nets must be installed, leaving enough space underneath so that if a worker falls, he won't hit anything below the net. Also, perimeter nets must reach out a minimum distance from the edge of the working area. The horizontal distance depends on the height of the fall. For example, if the fall is 5 feet or less, the net must extend 8 feet. Up to 10 feet, the net must extend 10 feet. And for any fall greater than 10 feet, the net must extend 13 feet. Once the net is in place as a system, you have to test it with a 400-pound bag of sand, according to OSHA requirements. The nets have to be inspected weekly and after impacts for wear, damage, or deterioration. All defective nets must be repaired or replaced immediately. And workers should remove any material or debris that falls into the net as soon as possible or no later than the end of the work shift. The third option for fall protection is the personal fall arrest system. These systems are used when no other systems are in place, during steel erection, near open-sided floors, for work on elevated platforms, and during roofing work. The system is made up of a full-body harness, a lanyard, and a tie-off or anchorage point. The harness distributes forces throughout the body and decreases the chance of injury.
The second component of a personal fall arrest system is a lanyard. There are several types and styles of lanyards available. Lanyards can be made of rope, nylon strap, or steel.
The rope lanyard stretches more than the nylon strap lanyard, but is more likely to be cut or damaged, so don't wrap it around a beam or sharp edge. Steel is very durable and should be used only with certain limitations in harsh work environments where other lanyards may be weakened. No matter what lanyard type or material is used, OSHA has set limits for the fall forces that workers can be exposed to. For example, if you're wearing a full-body harness, the force must be no more than 1,800 pounds. Here's an example of what the stopping forces would be with different lanyards. Say you have a 180-pound worker with a 6-foot rope lanyard. When he falls, the force on his body will be over 2,000 pounds. With a nylon strap lanyard, the force would be 2,800 pounds. And with the steel lanyard, around 4,000 pounds. All of these forces are much more than the 2,000-pound force that has been proven to be enough to seriously injure a person. One way to reduce these forces would be to use a shock-absorbing lanyard. If a worker falls, it can lengthen up to 3.5 feet. This allows for a soft, easy stop. Another variation of the shock-absorbing lanyard is the shock-absorbing pack. The pack can be attached in between the harness and the lanyard and works as a shock absorber if a worker falls. It's important to remember that a shock-absorbing pack must be used with steel lanyards. Because steel doesn't stretch, workers can be exposed to a tremendous force if they fall. Many brands of shock-absorbing packs and lanyards will display a warning strip if exposed to a fall. If this strip is seen, the pack or lanyard has to be destroyed. An option designed to increase worker comfort and not restrict movement are retractable lanyards. There are primarily two types of retractables: nylon strap and steel cable. Both take up slack in the lanyard material so it stays out of the worker's way. The units can be easily moved or permanently mounted in place. And if a worker slips, the braking mechanism locks quickly to limit the fall to 2 feet or less. All lanyards and retractables are connected to harnesses by locking snap hooks. The life and performance of personal fall arrest equipment can be maintained by visually inspecting it daily. A competent person must also thoroughly inspect it regularly. He or she should look for deterioration, faulty hook springs, and loose or damaged mountings. Frayed edges, broken fibers, pulled stitches, or chemical damage might also be a problem. The competent person should check D-rings and D-ring metal wear pads for distortion, cracks, breaks, and sharp edges. When checking lanyards, the worker should begin at one end and work to the other end. He or she should slowly rotate steel and rope lanyards to see all sides while looking for worn or broken strands. When inspecting a web lanyard, bending the webbing over a pipe will help check out each side. The snap hook should also be inspected for hook and eye distortion, cracks, corrosion, or pitted surfaces. The keeper or latch must fit into the tip of the hook without binding. The keeper's spring should exert enough force to firmly close the keeper. And once the keeper is closed, the locking system should prevent it from opening. And the manufacturer's instructions on proper cleaning and storage must always be followed. If a worker's total body and tool weight is more than 310 pounds, then his or her personal fall arrest system may have to be modified. And one place to start is the manufacturer. The final component of the personal fall arrest system is the anchor point. Some possible anchor points are steel structures, beams, or columns. New devices are becoming available regularly that provide safe, convenient anchor points. Here's a device that slides along a beam. This hand grip is designed to snap onto an overhead pipe. It will deform if you fall, but it won't come loose. Here's a system that clamps onto the flanges of steel decking. The automatic arrest system allows the worker to move in a 30-foot radius. It also includes a special swivel that shows if a worker has fallen, which means that a safety inspection is required. Here's a horizontal lifeline. Straps are placed around columns. Then a safety line with a built-in shock absorber and a tensioning device clips to the D-rings. The worker's lanyard fastens to stainless steel O-rings on the support line. The whole kit comes in a bucket. The manufacturer's directions take the place of a qualified person for installation. This bracket and D-ring is designed for anchoring into concrete. This strap with D-ring is designed to be placed over rebar at the form building stage. After the pour and cure, it's available for use. And here's a strap designed for use with wood frame construction. It's a one-time use device that is